The idea came to Dr. Eleanor West on a rainy Tuesday afternoon. She sat in her office at Riverside University, surrounded by textbooks and research papers, staring out the window as water streamed down the glass. For 15 years she had worked in forensic anthropology, studying what happens to bodies after death. Her work helped solve crimes, identify remains, and bring closure to families. But there was still so much they didn't understand about what happened beneath the soil. Eleanor tapped her pen against her desk, deep in thought. The problem had always been the same. They could only study decomposition by digging up remains at different stages. It was like trying to understand a movie by looking at random screenshots. What if they could watch the whole process unfold? What if they could see everything that happened after burial moment by moment? That's when the idea struck her. A camera, a specially designed camera inside a coffin. The next morning, Eleanor walked quickly across campus, her footsteps echoing in the empty hallway as she made her way to the office of her colleague, Dr. Thomas Chen. When she knocked on his door, Thomas looked up from his computer with tired eyes and a friendly smile. "You have that look," he said, gesturing for her to sit down. "The one that means either brilliance or trouble." "Maybe both," Eleanor replied, placing her notebook on his desk. "I think I've found a way to revolutionize how we study decomposition." For the next hour, Eleanor explained her idea. A transparent coffin equipped with cameras, sensors, and data transmission equipment. Everything would be ethically sourced. They would only use bodies donated to science with full consent. The study would provide unprecedented data about decomposition, potentially changing how they determine time of death in forensic cases. Thomas leaned back in his chair when she finished speaking. "It's bold," he said. "Very bold. But the ethics committee will have questions. Lots of them." "I know," Eleanor nodded. "But think about what we could learn. Think about how many cases we could solve with better data." Over the next few weeks, Eleanor refined her proposal. She worked late into the night researching similar studies, consulting with engineers about the technical aspects, and drafting responses to potential ethical concerns. The small apartment she shared with her cat became covered in notes and sketches. One evening, as she was reviewing her proposal for the 10th time, her phone rang. It was Thomas. "The committee wants to meet with you next week," he said. "They're interested but concerned." Eleanor took a deep breath. "I'll be ready." The ethics committee meeting took place in a wood-paneled room with large windows overlooking the university grounds. 7 professors from different departments sat around. A long table, their faces serious as Eleanor set up her presentation. "Dr. West," began the committee chair, a silver-haired woman with sharp eyes. "Your proposal is certainly unusual. We have significant concerns about dignity and respect for the deceased." Eleanor nodded. "I understand completely. That's why we've incorporated multiple safeguards." She clicked to the first slide of her presentation. "First, we'll only use donors who have specifically consented to this type of research. Second, all data will be anonymized and access will be strictly limited to the research team. Third, we've designed the study to be as respectful as possible while still gathering valuable scientific data." "And what exactly do you hope to learn?" asked a professor from the biology department. "Right now, our understanding of decomposition timelines is incomplete," Eleanor explained. "This affects everything from murder investigations to identifying remains after disasters. With real-time observation, we could document exactly how environmental factors influence decomposition, how different microorganisms contribute to the process, and how to more accurately determine time of death." For the next hour, Eleanor answered questions about every aspect of her proposed study: the technical specifications of the equipment, the security measures for the data, the protocols for handling unexpected situations. With each question, she felt more confident. They were asking the right questions, difficult but important ones. As the meeting drew to a close, the committee chair looked at Eleanor thoughtfully. "This is not a decision we can make today. We'll need time to discuss." "Of course," Eleanor replied, gathering her materials. "Thank you for your consideration." 2 weeks passed without word from the committee. Eleanor tried to focus on her other projects, But her mind kept returning to the proposal. Had she been too ambitious? Too controversial? Then, on a bright Friday morning, she received an email asking her to meet with the committee chair that afternoon. Eleanor arrived at the chair's office 10 minutes early, her stomach tight with anticipation. When she was called in, she found the chair alone, reviewing documents at her desk. "Please, sit down," the older woman said, gesturing to a chair. "The committee has reached a decision," she continued, folding her hands on the desk. "We've decided to approve your study with conditions." Eleanor felt a rush of excitement but kept her expression professional. "What conditions?" "First, you'll need to secure additional approvals from the State Regulatory Board. Second, you must establish a separate ethics oversight group specifically for this project. Third, any publications must be reviewed by the university legal team before submission." "I understand," Eleanor nodded. "Thank you." "Don't thank me yet," the chair said with a slight smile. "This won't be easy. There will be opposition, both inside and outside the university." "I know," Eleanor replied, "but I believe it's worth it." That evening, Eleanor called Thomas to share the news. They agreed to meet the following day to begin the real work: assembling a team, designing the equipment, securing the necessary permits, and finding appropriate donors. As she hung up the phone, Eleanor looked at the stack of research papers on her desk. For years, she had studied the dead to help the living. Now she had the chance to advance that mission in a way no one had attempted before. The next morning, Eleanor arrived at the university early. She spent some time walking around the campus grounds, watching students hurry to morning classes. Eventually, she found herself near the small plot of land that had been set aside for university research projects. This quiet corner, surrounded by trees, would likely be where their study would take place. Later that day, she and Thomas met in the laboratory to begin drafting plans for the equipment they would need. They were joined by Dr. Priya Sharma, ND, environmental scientist with expertise in soil composition, and Dr. James Williamson, an engineer who specialized in sensor technology. "We'll need cameras that can function in low light and high humidity," James explained, sketching on a whiteboard. "And they'll need to be positioned to capture multiple angles." "The data transmission is tricky," Thomas added. "We'll need a secure way to send information from underground without disturbing the site. And we'll need to monitor soil conditions constantly," Priya said. "Temperature, moisture, pH levels, everything affects decomposition rates." As they talked, their excitement grew. This wasn't just a study. It was a pioneering venture into uncharted scientific territory. Over the next few months, Eleanor worked tirelessly to bring the project to life. She secured additional funding from a forensic science foundation. She navigated the complex process of obtaining state approval. She met with potential donors and their families, explaining the importance of the research and answering their questions with honesty and compassion. There were setbacks, of course. A key piece of equipment failed during testing. A local newspaper published a sensationalized article about the study, leading to concerned calls from the public. One of their team members withdrew from the project after receiving criticism from colleagues. But for every setback, there was progress. The specially designed coffin, made of reinforced transparent material, was completed. The sensor array passed all tests with flying colors. A medical school agreed to help them find appropriate donors who were willing to contribute to forensic science after death. 6 months after the initial approval, Eleanor stood in her office looking at the final research protocol. Everything was in place. They had the approvals, the equipment, the team, and a suitable location. All they needed now was a donor. That afternoon, as Eleanor was reviewing data from a previous study, Thomas knocked on her door. His expression was serious, but there was an undercurrent of excitement in his voice. "The donor coordinator just called," he said. "They have someone who might be suitable. The family is supportive of scientific research and interested in our study." Eleanor took a deep breath. After months of preparation, they were about to begin a journey into the unknown. What they would discover beneath the soil might change forensic science forever. "Let's meet with them," she said, standing up from her desk. It's time to move forward. 2 days after Thomas delivered the news about a potential donor, Eleanor found herself sitting in a quiet conference room at the University Medical Center. The walls were painted a soft blue, and landscape photographs hung in simple frames. The room was designed to feel calm and welcoming, a place where difficult conversations could happen with dignity. Eleanor arranged her materials carefully on the table, a folder with information about the study, consent forms, and a tablet containing digital renderings of the equipment they would use. Thomas sat beside her, reviewing his notes one last time. "Are you nervous?" Thomas asked, keeping his voice low. Eleanor nodded slightly. "This isn't like our other research. It feels more personal." Before Thomas could respond, the door opened. A woman in her 60s with silver-streaked dark hair entered, followed by a younger man who shared her eyes and jawline. The family liaison from the medical center introduced them as Catherine and David Reynolds. "Thank you for coming," Eleanor said, standing to greet them. "I know this isn't an easy time for you." Catherine's eyes were tired but clear. "My husband was a science teacher for 40 years. He believed in education above all else. When we learned about your research program, it felt right." For the next hour, Eleanor explained every aspect of the study. She described how the transparent Coffin would be constructed, how the cameras and sensors would work, and what kind of data they hoped to collect. She was careful to be thorough, but sensitive, avoiding clinical language that might seem cold. "The study would last approximately 14 months, Eleanor explained. During that time, we would monitor changes that occur naturally after burial. This information could help solve crimes, identify remains after disasters, and advance our understanding of decomposition ecology." David leaned forward, his brow furrowed. "And everything will be handled with respect? My father was a proud man. He wouldn't want—" "Dignity is our highest priority," Thomas interjected gently. "All data will be anonymized. Access to visual information will be strictly limited to the core research team. We've designed protocols specifically to ensure respectful handling throughout the study." Catherine reached for her son's hand. "Your father also had a practical streak. He would say that once he's gone, his body should be useful." They talked for another half hour, addressing concerns and answering questions. By the end, Catherine seemed resolved, while David appeared thoughtful but no longer worried. "We'd like to sleep on it," Catherine said, "but I think this is what Robert would have wanted." 3 days later, Eleanor received a call. The Reynolds family had decided to participate in the study. Robert Reynolds, who was in hospice care with terminal cancer, had signed all the necessary consent forms himself after speaking with his family. The reality of their responsibility settled over Eleanor like a weight. This wasn't just a research project anymore. It was a promise to a dying man and his family. Promise to create meaning from loss. Over the next few weeks, the team worked feverishly to finalize preparations. The laboratory hummed with activity as engineers ran final tests on the equipment. Environmental scientists prepared the research site, installing ground sensors to monitor conditions around the burial area. Data security specialists created encrypted channels for information transmission and storage. Eleanor oversaw every detail, often working late into the night. She knew they would have only one chance to get this right. One rainy morning, Eleanor received the call they had been expecting but dreading. Robert Reynolds had passed away peacefully at home, surrounded by his family. The study would begin in 3 days. On the day of the burial, the sky was overcast but dry. The research site, located in a quiet corner of university grounds, had been prepared with meticulous care. A small tent sheltered the area from view, providing privacy and protecting the sensitive equipment. Eleanor arrived early, checking each component one last time. The transparent coffin, made of specialized material that would allow visual observation without compromising structural integrity, sat ready. Inside, cameras were positioned at carefully calculated angles. Sensors would monitor temperature, humidity, pressure, and chemical changes. A secure data transmission system would send encrypted information to their protected servers. "Everything looks good," said James, the engineer, after running a final diagnostic. "The system should function exactly as designed." "The soil sensors are all calibrated," Priya added. "We'll have continuous environmental data from inside and outside the coffin." Thomas approached Eleanor, speaking quietly. "The Reynolds family asked if they could have a few minutes here before we begin. I told them yes, I hope that was okay." "Of course," Eleanor nodded. "This is still a burial. We need to remember that." The team stepped away as Catherine, David, and a few other family members arrived. They stood together near the prepared grave, sometimes speaking softly to each other, sometimes silent. After about 15 minutes, Catherine approached Eleanor. "We're ready," she said simply. "Robert would be proud to be part of this." The burial proceeded with quiet efficiency. The university chaplain, who had been briefed about the unusual nature of the study, offered a short, dignified service. The specialized coffin was lowered carefully into place. Technicians made final adjustments to ensure all equipment was functioning properly before the grave was filled. By late afternoon, the site looked much like any other recent burial, a rectangle, of fresh soil with subtle equipment housing at one end, disguised to blend with the landscaping. Only the small weather station nearby suggested anything unusual. Back in the laboratory, Eleanor and Thomas watched as the first data began to appear on their monitors. Crystal-clear images showed the interior of the coffin from multiple angles. Graphs displayed temperature, humidity, and atmospheric composition in real time. Everything was working perfectly. "It's actually happening," Thomas said softly. "After all the planning, all the obstacles." Eleanor nodded, feeling a complex mix of emotions. Scientific excitement tempered by an acute awareness of the responsibility they had undertaken. Now the real work begins. The team established a rotation schedule. Someone would monitor the data at all times, watching for equipment malfunctions or unexpected developments. They set up alerts that would notify them of significant changes in any parameters. During the first week, they observed little visible change, though the sensors detected subtle shifts in temperature and atmospheric composition inside the coffin. Eleanor documented everything meticulously, comparing their observations with existing research on early-stage decomposition. By the second week, more noticeable changes began to appear. The cameras captured details that had never been documented so precisely before. Eleanor found herself frequently consulting with microbiologists to identify organisms that appeared in the images. "This is already challenging some of our assumptions," she told the team during their weekly meeting. "The sequence of microbial colonization is different from what textbooks describe. And look at these temperature patterns. They don't match our predictive models at all." As the study progressed, word spread through the scientific community. Eleanor began receiving emails from researchers around the world, asking about their methods and preliminary findings. Several forensic science journals expressed interest in publishing their results. 1 month into the study, Eleanor invited Catherine Reynolds to the laboratory. She felt it was important to show the family that their contribution was making a difference. "We're seeing things that have never been documented before," Eleanor explained, showing Catherine some of the non-sensitive data visualizations. "Your husband's gift to science is truly invaluable." Catherine's eyes grew damp, but she smiled. He would have loved being part of discovery. Science was everything to him. As the weeks passed, the team settled into a rhythm. Morning briefings to review overnight data. Midday analysis sessions to compare observations with existing research. Evening planning meetings to prepare for the next phase of the study. Eleanor found herself increasingly fascinated by the precision of nature's processes. There was an ordered sequence to decomposition that was both predictable and surprisingly variable. Each environmental factor, a rainy day, a temperature drop, a change in soil moisture, triggered cascading effects that they could now observe in unprecedented detail. 2 months into the study, during a routine overnight monitoring shift, Thomas noticed something unusual on one of the cameras. He immediately called Eleanor. "You need to see this," he said when she answered, his voice tense with excitement. Camera 3 is showing something completely unexpected. Eleanor drove to the lab immediately, her mind racing with possibilities. When she arrived, Thomas was hunched over a monitor, replaying a sequence of images. "Watch the lower right corner," he said, pointing to the screen. Eleanor leaned closer. At first, she saw nothing unusual. Then, a subtle movement caught her eye. Something was happening that none of their research had predicted, something that might change their understanding of decomposition ecology entirely. "Call the team," she said, not taking her eyes off the screen. "Everyone needs to see this." As she waited for the others to arrive, Eleanor felt a familiar thrill, the excitement of scientific discovery, of seeing something no one had documented before. But this time, it was mixed with a profound sense of responsibility. What they were witnessing wasn't just data. It was the result of a family's generosity, a teacher's final lesson to the world. Whatever they had discovered, it would be Robert Reynolds' legacy as much as theirs. And Eleanor was determined to make sure that legacy would benefit science for years to come. By 3 in the morning, the entire research team had gathered in the laboratory. The room buzzed with excitement as they crowded around the monitors watching the footage Thomas had discovered. Even those who had been woken from deep sleep were now fully alert, eyes wide as they observed something none of them had expected to see. "Play it again," Eleanor said, leaning forward in her chair. "Slow it down to half speed." Thomas adjusted the settings, and they watched once more. The time-lapse footage showed a subtle but unmistakable pattern forming on the surface of the coffin's interior. Tiny thread-like structures were spreading in an organized network, creating connections between areas that conventional science said shouldn't be connected. "It looks almost like a neural network," Priya whispered. "But that's impossible." James, the engineer, shook his head in disbelief. "I've never seen microorganisms behave this way. They're moving with purpose." "Not purpose," Eleanor corrected gently. "Just highly efficient adaptation. These microbes are responding to their environment in ways we've never been able to observe before." For hours, they analyzed the footage from every angle. They compared the visual data with readings from their sensors, looking for correlations between the unusual microbial activity and changes in temperature, humidity, or chemical composition. "Look at this," Thomas said, pointing to a graph on his screen. "Every time this network expands, there's a corresponding spike in nitrogen compounds, and the temperature rises by 0.3 degrees. They're accelerating decomposition," Eleanor realized, but in a controlled, systematic way. By sunrise, they had drafted a preliminary analysis of their discovery. A previously undocumented species of microorganism, or possibly a known species, behaving in an undocumented way, was creating efficient networks to break down organic material. These networks appeared to communicate with each other, sharing resources and adapting to changing conditions inside the coffin. "We need to identify these organisms," Eleanor said, rubbing her tired eyes. "Priya, can you take point on that? Work with the microbiology department to see if they can match these to known species." "Already on it," Priya nodded, typing rapidly on her laptop. "I've sent preliminary images to Dr. Winters. She's the best mycologist in the state." Eleanor turned to James. "We need to adjust camera 3 to get better resolution on these networks. Can we do that remotely, or does the equipment need physical adjustment?" "We designed for this possibility," James replied. "I can enhance the focus remotely. I'll also increase the frame rate to capture faster movements." Thomas looked concerned. "If we're dealing with an unknown microorganism, should we be worried about containment? Could there be any risk to the surrounding environment?" It was a good question, one that Eleanor had already been considering. "All our research suggests these are natural decomposers, just ones we haven't properly documented before. They're doing exactly what nature intended, just more efficiently than we expected. But you're right to be cautious. Let's increase soil monitoring around the site and check for any unusual activity beyond the coffin." As the team dispersed to their various tasks, Eleanor stayed behind, watching the monitors. The discovery was exciting from a scientific perspective, but she also felt a deeper significance. Nature had systems and processes that humans had barely begun to understand. Even in death, perhaps especially in death, life found a way to create order from chaos. Over the next few days, the team worked around the clock to document and analyze their discovery. Priya collaborated with microbiologists who identified the organisms as a rare variant of a known fungal species. What made them unusual wasn't their genetic makeup, but their behavior, the way they formed networks and shared resources. They're acting almost like a single organism, Dr. Winters, the mycologist, explained during a video conference. Individual cells are specializing and communicating with each other to optimize decomposition. I've never seen anything like it outside of highly evolved species. Eleanor asked the question that had been on everyone's mind. Is this behavior unique to our research site, or have we simply never had the opportunity to observe it before? Dr. Winters considered this thoughtfully. My guess would be the latter. Nature is full of elegant solutions that we've never seen because we haven't looked in the right way. Your study has created the perfect observation platform for processes that usually happen hidden from view. As they continued monitoring, other patterns emerged. The decomposition process wasn't following the textbook timeline. Certain stages were happening faster, others slower. The sequence itself was different in subtle but significant ways. We need to revise the forensic timeline models, Thomas said during their weekly team meeting. Based on what we're seeing, standard methods for determining time of death could be off by as much as 30% under certain conditions. The implications were enormous. Criminal cases, disaster victim identification, archaeological dating, all relied on understanding how bodies changed after death. If their observations proved consistent, it could lead to more accurate methods across multiple fields. 3 months into the study, Eleanor decided it was time to share some of their preliminary findings with the scientific community. She drafted a paper for a leading forensic journal, carefully anonymizing all data while preserving the scientific value of their observations. I want all of you to review this before we submit, she told the team, distributing copies of the draft. This is our first public statement about the study. It needs to be perfect, scientifically accurate, but also respectful of the human aspect of our research. The paper generated immediate interest when it was published. Eleanor began receiving calls and emails from researchers around the world, some skeptical, others enthusiastic. Several universities requested permission to establish similar studies, using the protocols Eleanor's team had developed. You've started something important, Thomas told her one evening as they reviewed the day's data. This could change how we approach decomposition studies forever. Eleanor nodded, feeling both pride and a sense of responsibility. We need to make sure it changes things for the better, that any future studies maintain the same ethical standards we've established. 4 months into the study, Eleanor invited Catherine Reynolds back to the laboratory. She wanted to share their discoveries with Robert's family, to show them how his contribution was advancing science. Catherine listened intently as Eleanor explained their findings in non-technical terms, showing her visualizations of the data without any distressing images. So these tiny organisms are helping the body return to nature more efficiently than anyone knew? Catherine asked, grasping the concept immediately. Exactly, Eleanor smiled. And because we've been able to observe the process in real time, we can create better methods for forensic science. Methods that might help bring closure to families who've lost loved ones in uncertain circumstances. Catherine's eyes grew damp. Robert would have loved knowing he contributed to that. He was always fascinated by how nature solved problems. As the study passed its halfway point, the team began preparing for the next phase of research. The dramatic site changes of early decomposition had given way to more subtle, long-term processes. These required different monitoring approaches and new analytical methods. We need to start thinking about the soil ecology now, Priya explained during a team meeting, how these changes affect the surrounding environment, and how the environment in turn affects decomposition. James nodded. I can adjust the external sensors to give us better data on the soil microbiome. We should be tracking changes at least 2 meters in every direction. As they refined their approach, Eleanor found herself reflecting on how the project had evolved. What had begun as a clinical scientific study had become something more profound, an exploration of the intricate relationships between life and death, between human bodies and the natural world that reclaimed them. One evening, as she was reviewing the day's data alone in the lab, Eleanor noticed something new on one of the monitors. The fungal networks they had been tracking for months were changing again, adapting to the latest phase of decomposition. But there was something else too, something she hadn't noticed before. The soil around the coffin was showing signs of increased fertility. Plants nearby were growing more vigorously than those just a few meters away. The process they were observing wasn't just about breaking down, it was about renewal. Eleanor sat back in her chair, a smile spreading across her face. They had set out to document what happened to bodies after death, but they were discovering something much more meaningful: how death itself nourished new life. She picked up her phone to call Thomas. This wasn't just another interesting data point. This was a fundamental insight into the cycles that connected all living things. And it had been Robert Reynolds, a science teacher to the end, who had helped them see it. The discovery of enhanced plant growth around the burial site changed the direction of the study. What had begun as research into decomposition for forensic purposes now expanded to include ecology and soil science. Eleanor and her team found themselves exploring not just how bodies break down after death, but how they contribute to new life. "We need to bring in a botanist," Eleanor told the team during their morning meeting. "Someone who can help us understand exactly what's happening with the plant life." Within days, Dr. Lily Chen, a botanist specializing in soil-plant interactions, joined the research team. She arrived at the laboratory with an enthusiasm that matched their own, eager to see the data they had collected. "This is fascinating," she said, studying the growth patterns in the soil surrounding the burial site. "The plants aren't just growing faster, they're healthier. Look at the leaf coloration, the stem strength. These are signs of optimal nutrition." Lily set up additional monitoring equipment around the site, taking soil samples at various distances from the coffin. She established a small control garden nearby, growing identical plants in soil that hadn't been affected by the decomposition process. "If we can identify exactly which compounds are creating this effect," she explained, "it could have implications for sustainable agriculture, natural fertilizers that work with soil microbiomes instead of disrupting them." As the team expanded their research focus, they also continued monitoring the original decomposition process. The network of microorganisms they had discovered was still evolving, adapting to each new phase of breakdown. By the 8th month of the study, they had documented 5 distinct phases, each with its own community of organisms working in concert. "It's like watching a succession of tiny civilizations," Thomas remarked one afternoon as they reviewed the latest footage. "Each one prepares the way for the next." Eleanor nodded, equally fascinated. "And each one is more efficient than we ever realized. The textbooks say this phase should take weeks, but these networks are completing it in days." Their second paper, published in a prestigious biology journal, drew even more attention than the first. This time, the interest came not just from forensic scientists but from ecologists, agricultural researchers, and environmental engineers. Eleanor found herself fielding calls from around the world, explaining their findings and methodology to curious colleagues. One call came from Dr. Miguel Santos, a renowned soil scientist from Brazil, who had pioneered research into rainforest regeneration after clearing. "Your discovery could help us understand how to rebuild soil fertility in damaged ecosystems," he explained. "If these microbial networks can be encouraged in depleted soil, we might accelerate forest recovery by decades." The potential applications of their research continued to expand. A pharmaceutical company contacted them about the possibility that some of the fungal species might produce compounds with medical applications. An environmental remediation firm wanted to know if similar processes could help break down pollutants in contaminated soil. "We never imagined the study would branch out in so many directions," Eleanor told Thomas as they walked the perimeter of the research site one crisp fall morning. The area around the burial had been cordoned off with simple fencing, protecting it from foot traffic while allowing the research team full access. That's how the best science works, Thomas replied. You start with one clear question, but the answers lead you to questions you never thought to ask. As they completed a circuit of the site, Eleanor noticed something she hadn't seen before. Just outside their monitoring area, a cluster of mushrooms had appeared overnight. Small, delicate structures with caps like tiny umbrellas. Those weren't there yesterday, she said, kneeling down to look more closely without touching them. Thomas crouched beside her. They look like Amanita muscaria, but the coloring is different, more purple than red. Eleanor took photos from several angles, careful not to disturb the mushrooms. Let's show these to Lily. They might be connected to our fungal networks. Back in the lab, Lily examined the photos with growing excitement. These are extremely unusual. The structure is similar to known species, but I've never seen this particular variant. We should take spore samples. When they returned to the site, with collection equipment, they found the mushrooms had already released their spores. Fine, purple-tinged dust that sparkled faintly in the morning light. Lily carefully collected samples of the dust and the mushrooms themselves, eager to examine them under the microscope. What they discovered in the laboratory left them all speechless. The spores contained compounds that were completely unknown to science, complex molecules with structures unlike anything in their chemical databases. We need to bring in a biochemist, Lily said, still staring at the molecular diagram on her computer screen. These compounds could have all sorts of properties we can't even guess at. Dr. Wei Jiang, a biochemist from the university's medical research department, joined them the next day. He spent hours analyzing the mysterious compounds, running them through every test he could think of. These molecules have remarkable properties, he finally announced. They appear to enhance cellular regeneration in plant tissue, but they're not toxic to mammalian cells. In fact, preliminary tests suggest they might have beneficial effects. The implications were staggering. The decomposition process they were studying wasn't just returning nutrients to the soil, it was creating entirely new compounds that might have applications in medicine, agriculture, and environmental restoration. As the one-year mark of their study approached, Eleanor organized a comprehensive review of all they had learned. The team gathered in the conference room, where whiteboards covered in diagrams and timelines lined the walls. Digital displays showed time-lapse footage of the changes they had documented over the past 12 months. We've made more discoveries in 1 year than I expected to make in my entire career, Eleanor told the team. But we're only beginning to understand what we're seeing. Thomas nodded. The question now is where we focus our efforts for the remaining months of the study. They debated various approaches. Some team members wanted to concentrate on the microbial networks and their unusual behavior. Others were more interested in the soil fertility effects and the mysterious compounds produced by the mushrooms. There were compelling arguments for each direction. We don't have to choose just one, Eleanor finally said. We have enough data and expertise to pursue multiple avenues of research. Let's divide into smaller teams, each focusing on a specific aspect of what we've discovered. The plan energized everyone. By the end of the day, they had established 3 research tracks, one focusing on the microbial networks and their implications for forensic science, one studying the soil fertility effects and their potential for agriculture, and one investigating the mysterious compounds produced by the fungi. As they were finalizing the details, Eleanor received an unexpected call. It was Catherine Reynolds. I hope I'm not interrupting anything important, Catherine said when Eleanor answered. Not at all, Eleanor assured her. It's always good to hear from you. How are you doing? I'm well, thank you, Catherine replied. I was calling because tomorrow would have been Robert's birthday. The family is having a small gathering to remember him, and we were wondering if you might join us. We'd love to hear more about how the research is progressing. Eleanor felt deeply touched by the invitation. I'd be honored to come, and I have so much to tell you about what we've discovered, thanks to Robert's contribution. The next evening, Eleanor found herself sitting in the Reynolds' living room, surrounded by family photos and mementos of Robert's life. His grandchildren played quietly in the corner while adults shared stories and memories. It wasn't a somber occasion, but a celebration of a life well lived. When Catherine asked Eleanor to tell them about the research, all conversation stopped. Everyone listened intently as Eleanor explained in simple terms how their study had expanded, far beyond its original scope, how Robert's gift to science was helping them understand not just death but life itself. The things we're learning could someday help grow food more efficiently, she told them, or restore forests that have been cut down, or even develop new medicines, all because of what Robert helped us discover. David, Robert's son, shook his head in amazement. Dad always said that teaching was about planting seeds that would grow long after you were gone. I don't think he ever imagined how literally that would turn out to be true. As Eleanor drove home that night, she reflected on the unexpected journey their research had taken. What had begun as a clinical study of decomposition had become an exploration of life's continuous cycle. How death fed new life. How endings created beginnings. And it had all started with a simple idea: to place a camera where no one had thought to look before. To witness what had always happened in darkness and bring it into the light of scientific understanding. Back in her office the next morning, Eleanor found Thomas already reviewing the overnight data. He looked up with an expression of disbelief and excitement. "You need to see this," he said, turning his monitor toward her. "It started happening about 3 hours ago." Eleanor leaned closer, not sure what she was seeing at first. Then, as she understood, her eyes widened in amazement. "That's not possible," she whispered. But the evidence was right there on the screen, undeniable and revolutionary. What they were witnessing would change their understanding of natural processes forever. Eleanor stared at the monitor, trying to make sense of what she was seeing. The images showed something so unexpected, so contrary to everything they thought they knew, that her mind struggled to accept it. The tissue at certain points in the coffin wasn't breaking down anymore. Instead, it was transforming. "Is this some kind of error in the imaging system?" she asked, her voice barely above a whisper. Thomas shook his head. "I checked everything 3 times. All systems are functioning normally. This is really happening." What they were witnessing defied conventional understanding. Certain cells at specific points in the decomposition process weren't dying. They were changing. The fungal networks they had been studying appeared to be integrating with these cells, creating hybrid structures that were neither fully human tissue nor fully fungal. "We need to call everyone in," Eleanor said, already reaching for her phone. "And we need to increase security around the site. No one outside the core team should know about this until we understand what we're seeing." Within hours, the entire research team had gathered in the laboratory. The atmosphere was electric, with a mixture of excitement, disbelief, and even a touch of fear at the unknown. "I've never seen anything like this in 30 years of microbiology," Dr. Winter said, examining the footage. "These fungi aren't just consuming the tissue, they're repurposing it." Lily, the botanist, leaned forward. "It reminds me of certain plant symbiotic relationships, where 2 species essentially become one organism. But I've never seen it happen with human tissue before." "Could it be some kind of preservation process?" Priya suggested. "Maybe these particular fungi don't break down certain cells but instead use them as scaffolding for their own structures." Dr. Zhang, the biochemist, was already running analyses on the mysterious compounds they had discovered in the mushroom spores. "There might be a connection between these compounds and what we're seeing now. They could be altering cellular processes in ways we don't understand yet." For the next several days, the team worked around the clock, documenting and analyzing this unprecedented phenomenon. They brought in additional experts under strict confidentiality agreements: a cellular biologist, a genetics specialist, even a physicist who specialized in self-organizing systems. What emerged from their collective analysis was a theory so revolutionary that Eleanor was hesitant to even put it in writing. "We think we're observing a new form of biological transformation," she finally explained during a closed-door meeting with the university's scientific ethics committee. "Not decomposition as we've always understood it, but a kind of biological recycling. The fungi aren't just breaking down the tissue. They're incorporating elements of it into new structures that retain certain properties of the original cells." The head of the committee, a stern woman with decades of scientific experience, looked skeptical. Are you suggesting some form of reanimation? Because that would raise serious ethical concerns. No, nothing like that, Eleanor clarified, quickly. These aren't living human cells anymore. They're fungal structures that have incorporated certain cellular components, proteins, lipids, even fragments of DNA, into their own biology. It's more like upcycling at a molecular level. The implications were enormous. If certain biological materials could be preserved and repurposed rather than simply decomposed, it could revolutionize everything from environmental waste management to tissue engineering. We need to be extremely careful how we present this, Thomas said after the meeting. If it's misunderstood or sensationalized, it could create panic or false hopes. Eleanor nodded. We'll focus on the scientific process in our paper, just the observable facts without speculation about applications or implications. Let the scientific community draw its own conclusions after rigorous peer review. As they prepared their findings for publication, Eleanor thought constantly about the Reynolds family. They deserved to know what their husband and father's contribution to science had revealed. But how could she explain something so complex and potentially unsettling? After much consideration, she invited Catherine to the laboratory again. This time, she showed her only carefully selected images and data visualizations, focusing on the beauty and elegance of the natural processes they had discovered. What we're seeing is how nature ensures that nothing is ever truly lost, Eleanor explained. Elements of what makes us who we are, down to the molecular level, can become part of new life forms. It's a kind of continuity we never fully understood before. Catherine listened thoughtfully, asking surprisingly insightful questions. At the end, she smiled. Robert always said we're all stardust, that the elements in our bodies were forged in stars billions of years ago. He would have loved knowing that even after death, parts of us continue in new forms. As the study entered its final months, the team focused on documenting the complete cycle of transformation they had discovered. They mapped the genetic exchanges between the fungi and the human tissue. They analyzed the new compounds being created. They studied the effects on surrounding soil and plant life. What emerged was a picture of nature far more complex and interconnected than anyone had imagined. Death wasn't simply an ending, but part of a continuous cycle of transformation. Materials, energy, even information in the form of DNA were passed from one life form to another in an endless dance of renewal. We need a new vocabulary, Dr. Winters said during one of their discussions. Words like death and decomposition don't accurately describe what we're seeing. This is more like transformation, renewal, continuity. As they prepared their final research paper, Eleanor found herself reflecting on how far they had come from their original purpose. They had set out to improve forensic timeline models, a worthy but limited goal. Instead, they had stumbled upon insights that might change humanity's understanding of life and death themselves. 14 months after the study began, the team gathered at the research site for a final day of data collection. The next day, following the protocols they had established at the beginning, they would carefully remove all their equipment and return the site to its natural state. It feels strange to be ending, Priya said as they checked the sensors one last time. There's still so much we don't understand. That's how science always works, Thomas replied. Every answer leads to 10 new questions. We've opened a door. Others will step through it after us. That evening they held a small ceremony at the site. It wasn't part of the official protocol, but it felt right to mark the end of such a momentous journey. Each team member spoke briefly about what the study had meant to them personally and professionally. When it was Eleanor's turn, she found herself unexpectedly emotional. When we placed a camera where no one had looked before, we thought we were studying death, she said. Instead, we discovered something profound about life, its resilience, its interconnectedness, its endless capacity for renewal. Robert Reynolds gave us more than data. He gave us a new way of seeing the world. The next morning, as they carefully dismantled their equipment, Catherine Reynolds arrived with a small stone marker. With the university's permission, she placed it at the edge of the site. The simple inscription read, Robert Reynolds, Teacher in Life, Teacher in Death, 1958-2023. In the weeks that followed, their final paper was published in one of the world's most prestigious scientific journals. The response was immediate and overwhelming. Some in the scientific community were skeptical, demanding more evidence and independent verification. Others were excited by the possibilities their discoveries suggested. Universities around the world began establishing their own research programs based on Eleanor's protocols. Funding poured in for studies exploring the applications of what they had discovered. Everything from improved forensic methods to new approaches for environmental restoration. 6 months after the end of the study, Eleanor received a letter. It came from a small village in Costa Rica, where Dr. Miguel Santos had been working on rainforest regeneration. Enclosed were photographs of test plots where he had introduced some of the fungal species they had identified. The difference between the treated areas and control plots was striking. Where once there had been depleted soil, new growth flourished, vibrant, diverse, and healthy. Your discovery is helping us heal the earth, Miguel wrote. What began in a coffin is now bringing new life to forests that were dying. Eleanor shared the letter with Catherine Reynolds, who kept in regular contact with the research team. As they looked at the photos together, Catherine smiled through tears. Robert would have loved knowing that his final act on Earth was helping forests grow, she said softly. He always told his students that the most important thing they could do was plant seeds for the future. A year after the study ended, Eleanor stood at a podium in Stockholm preparing to accept a prestigious scientific award on behalf of the entire research team. As she looked out at the audience, she saw Catherine and David Reynolds sitting in the front row. Our research began with a simple question about what happens after death, she told the audience. What we discovered was that death itself is not what we thought it was. It's not an ending, but a transformation, a passing of the torch from one form of life to another. In understanding this process better, we've gained insights that may help us heal environments, grow food more efficiently, and develop new medical treatments. She paused, looking directly at the Reynolds family. But the most important thing we learned came not from our data, but from the journey itself. Science is about looking where others haven't thought to look, about questioning what we think we know, and about recognizing that the greatest discoveries often come from the most unexpected places. As applause filled the hall, Eleanor thought about the simple camera they had placed in a coffin nearly 3 years earlier. They had set out to observe darkness and endings. Instead, they had discovered light and beginnings, and that, she reflected, was the greatest discovery of all.